Space travel is fast coming up as a potential solution to every problem facing Earth. So how achievable is it really? While the recent advancements in fields like robotics, artificial intelligence, navigation, communications, rocket design, and others have allowed humanity to explore further into space than ever before, we still need to solve many problems before we can finally leave Earth and settle among the stars. Number 10. Bone loss. Bone loss is one of the most debilitating effects future spacefarers are likely to face on long-term space missions. Despite their hard, unchanging appearance, bones are actually quite flexible as they continuously remodel themselves according to the amount of weight that they carry. As gravity exerts a continuous force on the body, human bones on Earth grow to be quite strong and sturdy. In space or other microgravity environments, however, bones start to lose that strength at a rapid rate. It's not a problem for short-term flights, but for longer-term missions to Mars and beyond, it's a significant obstacle, one that's unlikely to be resolved anytime soon. On average, astronauts lose about 1 to 2% of bone mineral density every month. One study found that during missions that last 6 months or longer, they could experience bone loss equivalent to about 2 decades of aging. On a 3-year mission to Mars, it could even be as high as 50%, making it impossible to return to Earth's gravity without experiencing some serious health issues. Number 9. Navigation. Navigation is something most of us take for granted. Now it's possible to pinpoint your location down to a few meters almost anywhere on Earth thanks to a steady stream of satellite information from state-of-the-art positioning systems like America's GPS and the European Union's Galileo. Even without them, one could still use other, more old-school methods of navigation to find their way around the world, like the magnetic compass. In space, however, things aren't that clear. While many countries do have their own deep space satellite networks to assist their operations in space, they only work over relatively short distances. Space navigators of the future would have to be adept at calculating their position, current speed, and other flight parameters from a constantly moving set of references. This is because everything in space is consistently in motion. NASA is currently working on a system called the DPS, or the Deep Space Positioning System, to provide navigation within the solar system, which would be required if we ever hope to make the trip to Mars. Beyond that, however, navigation remains one of the biggest unsolved challenges for future space travelers. Number 8. Heart atrophy. Heart atrophy is another major unresolved health issue astronauts are likely to face on long-distance space flights. Simply speaking, the human heart develops to be quite strong on Earth as it needs to work against gravity to pump blood from different organs. In the microgravity environment of space, however, that stress no longer exists. Studies have found that the hearts of astronauts that spend long periods of time in space develop to be more spherical than elongated, resulting in a continuous loss of muscle mass. To counter that, astronauts have to regularly exercise to keep their muscle mass consistent, though we're only talking about a few months here. For years-long trips to Mars and other planets, the loss could be permanent, posing a major challenge to their well-being once they return back to Earth's gravity. Number 7. Radiation. Space radiation is easily one of the most limiting factors for long-distance space travel. While some amount of radiation exists everywhere on Earth, even in the air we breathe, it's not as harmful as the kind of things flying around in space, from harmful gamma and X-rays to neutron particles that can damage or even kill living cells. Thankfully, Earth's atmosphere and magnetic field protect us from most of that, though in space, that protection no longer exists. Presently, we have no data on how prolonged cosmic radiation affects the human body, as manned missions are currently only flown within low Earth orbits where the Earth's magnetic field still exists. While modern spacecrafts and spacesuits are equipped with special shielding measures against radiation, we're not sure if they'd help on longer missions like the one planned to Mars. Number 6. Space debris. Currently, the US Department of Defense is tracking more than 27,000 pieces of potentially dangerous human-made debris floating around in low Earth orbit. If we include the smaller pieces, that number could be as high as 500,000, mostly made up of junk from previous rocket launches and collisions with space rocks. Space debris is fast coming up as a major problem for future missions to space. Already, there are so many rogue objects in orbit around Earth that navigators have to maneuver around them to avoid collisions. Collisions still do happen though, like when a Chinese satellite was severely damaged by debris from an old Russian rocket back in 2021, creating at least 37 new pieces of debris. As we launch more and more rockets, probes, and satellites into space, the problem is only going to get bigger and more difficult to solve. Number 5. A new age of warfare. While we've seen many wars around the world since World War II, it has been a period of relative peace among major military powers. The deterrence of nuclear weapons has, at least for the time being, made the global industrial wars of the 20th century rather obsolete. With the colonization and inevitable militarization of space, however, that deterrence is about to go away, and it's going to happen pretty soon too. While the Outer Space Treaty of 1967 prohibits the armament of space in any way, that hasn't stopped multiple countries, including Russia, the US, India, China, China and others from putting various kinds of military hardware into orbit. Military conflict in space doesn't just pose a threat to peace and stability on Earth, it could also potentially block anyone else from launching their own space missions. Imagine the amount of space debris left in the aftermath of a full-scale battle between large, nuclear-armed superpowers. Number 4. The Outer Limit. Popular fantasies about space travel almost take it for granted that would someday solve the mysteries of scaling the universe, allowing us to travel to other galaxies and star systems outside the Milky Way and beyond. They assume that intergalactic travel is only a matter of scientific progress and tinkering with the laws of nature, and that the universe is a static and unchanging place. Unfortunately, there's a good chance that we'll never be able to go beyond a certain point in space. As the glow of distant stars and other objects accelerates away from us, it'll get more and more difficult to observe them, even with our strongest telescopes. If we were to leave at the speed of light right now, we'd still only be able to reach about 3% of the currently observable universe, a sphere that's consistently shrinking with time. As enough time passes, everything beyond the local group of galaxies, which includes the Milky Way, Andromeda, and Triangulum, along with 50 or so smaller galaxies, would be inaccessible. Number 3. Reproduction. Until now, no one has had sex in space, or at least not that we know of. It's an incredibly difficult, almost impossible feat to achieve in microgravity due to the mechanics involved. Studies on astronauts that spend longer periods in orbit suggest that there's a significant drop in sex drive too, making it all the more difficult to repopulate future colonies in space. On top of that, many of the biological processes behind human reproduction require Earth's gravity and low radiation levels to complete. Experiments on various animals have been inconclusive, though some of them do report abnormalities like lower sperm counts and other sexual health issues. Moreover, our bodies work very differently from, say, that of a rat. So far, there have been no studies on the effects of microgravity and space travel and space levels of radiation on a fully developed human embryo. Number 2. Gravity. By now, it's clear that gravity is inextricably linked to all life on Earth, from regulating essential life processes like reproduction to maintaining an atmosphere that protects us in many ways. It's almost a prerequisite for life as we know it, much like water or sunlight. Without it, it'd be extremely difficult, if not outright impossible, to set up long-lasting, sustainable colonies in space. Sadly, we still don't have any way to replicate it outside Earth, not without other massive side effects. While artificial gravity could be introduced with motion, we have no way of maintaining a stable, consistent gravitational field. According to one theory, it could be done with anti-gravitational or negatively charged gravity particles, though till now, no such particle has ever been found. Number 1. What about Earth? The idea that it's possible to leave Earth and all its problems behind within the next few decades isn't just scientifically implausible, it also makes us complacent towards those problems. While issues like climate change, widespread food shortages, global hunger, political conflict, and others may seem too big to tackle right now, they're relatively much easier to solve than the almost impossible task of making another planet habitable for life. Moreover, there are few historical examples of humans going to another inhospitable environment and living there, even right here on Earth. It'd be far easier to, say, terraform Antarctica for human life than Mars, though the idea just never took off, likely because terraformed Antarctica would likely still be a terrible place to live. Earth provides a naturally supportive environment for life to thrive, something that could never truly be replicated in an alien environment.